Okay, now topic of today's discussion is Wheatstone bridge, and Wheatstone bridge is utilizing the Kirchhoff rule that we have studied. Okay, this is the first application where the Kirchhoff rule is utilized in our theory part. Now see, Wheatstone bridge is the circuit which is shown in this figure. This is the circuit which is considered, or it is known as the Wheatstone bridge. Now see, Wheatstone bridge is having 4 resistors, 1, 2, 3, 4. They are R1, R2, R3 and R4. Okay. Now across one pair of diagonal of this square which is made by this 4 resistor. So one pair of diagonal, if you consider this point A and C, then across A and C a battery is joined or a cell is joined. Now if you consider the other 2 vertices of the square, then a galvanometer is joined between these 2 vertices, that is B and D, and this galvanometer is a device which is having a use to detect the electric current. It does not measure, it detects the electric current. Okay. Now we are considering that there is no internal resistance of the cell. Okay. Now the current flowing across all the resistor as well as this galvanometer. So current will pass through this R1, R2, R3 and R4. Okay. Say current I1 is passing through R1, current I2 is passing through R2, current I3 is passing through R3 and R4 is passing through, or we can say I4. I4 current is passing through the resistor R4. Current Ig is flowing through this galvanometer. Galvanometer is having the resistance, is having the current Ig. Now see, this current through galvanometer we want to make 0. So we shall adjust this R1, R2, R3 and R4 resistors in such a way that current through galvanometer becomes 0. So try to understand, if one of the resistance is unknown, the basic use of Wheatstone bridge is to determine the unknown resistance. See, if R4 is unknown, then do not touch that R4. That value is unknown for us, so we are not adjusting it because that we want to find out. So we have to adjust R1, R2 and R3 in such a way that the galvanometer which is having certain current, say Ig, that becomes 0. So you have to have the adjustment of R1, R2 and R3 in such a way that the galvanometer does not have any current. So Ig becomes 0. So try to understand now, when Ig becomes 0, what happens? This I2 current which is flowing in this direction, that is AB direction, current is not going through galvanometer. So this I2 current will go to this branch BC. So here the I4 current which is written will be having the same value as I2. And here also similarly I1 current is flowing. This is a junction point, branch point. So we have this convention, or we have this conviction that okay, now the current will go this side. But we have adjusted these resistors in such a way that the galvanometer is not having any current. So I1 current which is flowing will directly go to this branch DC. Okay, so I1 is equal to I3. Current is not going through the galvanometer. So here I1 is equal to I3 and I2 is equal to I4. Now we are applying Kirchhoff's second rule in this ADBA branch. Now you consider this ADBA loop, rather not branch, ADBA loop. Okay. So if you are going with the current in AD direction, A to D you are moving with the current, So minus I1 R1. So first step will be minus I1 R1. Then you are going through this DB branch, no current is there, so 0. Okay. Now you go through this BA branch, current is in this direction and you are moving in this direction, opposite to your movement. So plus I2 R2 and is equal to 0. So we can say I1 R1 is taken on the other side, so it becomes positive. So I1 R1 is equal to I2 R2, that is our first result. Similarly for BCDB loop, you go in this direction BC with the current you are moving, so minus I4 R4. Then you are moving in this direction, current is in this direction, both are opposite, so plus I3 R3, so plus I3 R3, and in this DB branch there is no current, so we write 0 is equal to 0. So I3 R3 is equal to I4 R4. These are the two results. Now take the ratio of these two results. So I1 R1 upon I3 R3, I2 R2 upon I4 R4. Now as you know, I1 is equal to I3, okay, and I2 is equal to I4. These two, I1 I3 and I2 I4, will be cancelled out. You will have R1 upon R3 is equal to R2 upon R4, and our R4 is say unknown resistance. Then R4 can be made as a subject of formula. R4 can be made as a subject of formula, and R4 is equal to R2 into R3 upon R1. So this way you can find out the unknown resistance with the help of this Wheatstone bridge. Okay, thank you very much.